All right, we are live now. Hello everyone, welcome to Chennai Java community. Today we have Reza with us to give talk on applying domain-driven design blueprints using Jakarta EE. Reza is now working as a principal program manager for Java on Azure at Microsoft. He has a decades of experience with technology leadership, enterprise architecture, and consulting. He has been working with the Java EE since its inception, and he helped big companies like eBay, Nokia, Comcast, etc., in their enterprise architecture planning and with using technologies like Java EE and Spring. Furthermore, he also wrote a book on EJB in action, which is also available in Manning. You can, if you are interested, you can go and check it out. Not only that, but he is also a frequent speaker at various Java user groups and conferences like Java One, DevOps, etc. Today, with his talk about applied domain-driven design, he will demonstrate how we can apply DDD elegantly using an open source project called Eclipse Cargo Tracker. In this talk, we are going to learn concepts like entities, value objects, aggregates, and repositories with realistic code examples. We will also see concepts like bounded context, which are very much important in designing microservices. Without further ado, please join me welcoming Reza to virtual stage. During your talk, if you have any questions, please feel free to leave them in the comments. I will take them to speaker. Reza, stage is yours.
All right, excellent. I think it's like late afternoon, early evening for you guys. It's a fine Saturday morning, very early Saturday morning, about 7:30 a.m. here. So anyway, it's really good to be here. I've spoken at the Chennai Tech many years ago. I think it's almost, I almost want to say it's been 7 to 8 years ago. So it's good to see you guys. Good to come back here again. Actually, did a talk back then. I did the talk in person. So hopefully I get to meet you guys in person at some point. But at least it's good to see you alive and kicking after all these years. And also, again, happy to do this talk with you. This is a sort of an interesting talk. It's not really part of my day job, as was mentioned in my day job. I work for Microsoft, principal program manager for Java on Azure. This is actually a side project that I do. It's part. I think of it as doing it on behalf of the Jakarta EE ambassadors. I won't talk too much about the Jakarta EE ambassadors in this talk today. I just want to mention it and use the theme so to encourage you to kind of go and do a little bit more research on it. At the end of the day, the fundamental project, my little side project that we're talking about here, actually is part of the Eclipse Foundation. It's an official part of the overall Jakarta EE umbrella of projects. It's called EE4J set of projects. But basically, you can think of it not as this is Jakarta EE spec, but sort of part of the overall Jakarta EE initiative at the Eclipse Foundation. So yeah, basically this talk is, I think, a little bit self-explanatory in a way. Basically, we're taking domain-driven design, which is, if you will, an architectural way of thinking, and then seeing how that applies to Jakarta EE in particular. And in fact, even if you're not using Jakarta EE, probably 80 to 90% of what I have to tell you is going to be applicable to, in general, in any Java project. It's not like it's that specific to Jakarta EE in particular. There is some Jakarta EE specific parts to it, obviously, but it's not entirely based on Jakarta EE either. Whatever the code examples are, is relatively applicable. Is relatively easily applicable in most Java projects these days. So the other thing is, do ask questions throughout, please. So I don't usually do questions at the very end, just because it's kind of a waste of time. You always say, "Oh, I'm going to save 15 minutes, to do Q&A later," and then there is no Q&A sometimes, and then you just lost 15 minutes. I think it's better if we just, like, if you have a question on your mind, just go ahead and post it on YouTube. I'm not on YouTube. I won't be able to see it directly, but I will pause every now and then. Moderators can help us out. in that regard. So yeah, if you have questions, just go ahead and post them on YouTube throughout, and I will pick up the questions as we go. And hopefully it'll show up on here on my comments bar as well. So if I'm looking in this direction, that's what I'm looking at instead of looking at you. All right, so let's go ahead and get rolling. This is the slide deck. It is available out there if you want to take a look at it. And let's move on. All right, so basically, this is the project we're talking about. It's called Cargo Tracker. Very specifically, it's called Eclipse Cargo Tracker. And it has a little bit of history behind it. This is not a new project, actually. I started this project. This project itself is close to 7 or 8 or maybe even 10 years old. I started it back when I was actually working for Sun Oracle. And it's a result of something that I thought is valuable to the Jakarta EE ecosystem to do. So in order to really understand the origins of this talk, you need to dial back almost 20-25 years back when I was just starting up with server-side Java back in the day. It was J2EE. And before J2EE came about, there was sort of the servlet project, and there was a little sort of experimental project, some microsystems that got started. And at that point in time, I was actually I was working as a consultant. And I've got to be honest with you, like looking at the projects back then, it was really scary, because every single project would be different. People would just be doing whatever patterns and whatever code that they want to write. Sometimes there was no structure to the code whatsoever. It was these like giant JSP pages with a bunch of code thrown in there, and it was just mayhem. And maintaining those projects, man, I really feel bad for people that had to develop and maintain those projects, and I hope those projects are no longer around, and at least have been re-architected to some extent. Now, out of all that chaos and mayhem came about actually something very, very nice. And that is called the J2EE blueprints. Back in the day, it was called, also known as the Java Pet Store. It was sort of the canonical application that you would look at in order to understand, how to apply J2EE. And it was part of the official J2EE projects. It was a J2EE blueprint, literally. This project actually is one of the most impactful architecture projects in our industry. People do not give it enough credit, this project. What they did in this project is basically see that there was this chaos and try to bring about order. And the way they did it was they looked at the Gang of Four design patterns. And Gang of Four design patterns at that point in time was very, very new. It literally almost brand spanking new, like 2 or 3 years. Maybe the book was written, maybe even not a year before they started the J2E blueprint or Java Pet Store concept. And basically what they did was they said that, okay, we know there's these things called software design patterns, and they apply to Java. The Gang of Four design patterns is really nothing much more than design patterns book applying these design patterns to Java. And we can adopt these design patterns into J2EE, and we can also expand them. So as a result, you had a recipe or a blueprint of how to go about developing these server-side architectures in a standardized, systematic way, as opposed to just hodgepodge doing whatever it is that you feel like. It sort of gave us a vocabulary, common vocabulary that we can all understand. And believe it or not, the work that was done back then is still relevant. Almost 20, at least 20 years ago, this was. Even today, if you look at things like, if you're using words like DAO or DTO or data transfer object or proxy or factory applicable to server-side projects, these are all things that were developed back then. Or for service facade, right? Session facade. These are all basically invented as part of the J2E blueprints. So huge impact in our industry really from that project. Now, of course, that was early days, right? So anything that you know is sort of an early technological project, it's hardly going to be perfect. And J2E Blueprints and Java Bitstore was not perfect, right, by any means. In fact, one of the biggest problems that it had was it actually sort of defeated the core value proposition of object orientation, and made a lot of those systems, while they gave it some structure. Basically, it gave it like a sort of procedural COBOL-like structure, and it went away from the main things that you would get out of object-oriented development. So then came along this guy called Eric Evans, and this guy came along at just about at the right time. Also, he came out when not Spring Boot, but the Spring framework was getting popularized, when Hibernate as an open source project was getting popularized. And basically, he realized that, okay, if you use these Spring framework and Hibernate projects, you can actually, you don't have to, you can overcome the limitations that are there in the technology and in the architectural style of J2E blueprints or the Java pet store, and you can do something that goes back to the essential roots of object-oriented analysis and design. And believe it or not, domain-driven design actually is not so new. It's mostly recycled ideas that were there at the very beginning of object-oriented development, going back to even Lisp or things of that nature. So this is even older ideas that are sort of getting recycled and repolished and rebranded almost. And I obviously knew all of those as well, right? At that point in time, for me, it was from school, from, learning about object-oriented development and analysis in school, those concepts, as to why you would want to do this in the first place. And basically, that movement created sort of a replacement to the J2E blueprints, and it itself has had a little bit of success. I'm sad to say it, right? Because it actually deserves a little bit more success than it has had. But it's there, right? So it's an answer to sort of some weaknesses in the old J2E pet store patterns that still is surprisingly popular. And it goes back to object-oriented analysis and development. And at that point in time, again, I was a consultant when all of this was happening. And I said, okay, in my projects, I'm not doing, well, I did a little bit of Spring and Hibernate, but primarily at that, I was still doing a lot of J2E based development. And I was just beginning with Java EE5 at that point in time, which actually just took ideas from Spring and Hibernate and improved on them. Namely, they created annotations for the very first time in Java EE5. And I said, hey, I don't need to do this at all. There's this other thing called DDD. And because we're no longer doing EJB2 based development, and we now have Java E5, Java E6, and we have dependency injection, we have POJO based programming, we have annotations, we can actually do this DDD thing in Java E or Jakarta E. So in my projects, I began to do that. I began to successfully apply those concepts there. And when I came to Sun and Oracle, I said, hey, here's what I've been doing for a while. Are you interested in this? They said, yeah, absolutely. Yeah, so they actually, the purpose of the original Cargo Tracker project, which was part of the Java E umbrella of projects, was to actually replace the Java Pet Store or replace the J2E blueprints. So it sort of comes everything. It brings everything full circle. It sort of brought back the idea that originated with J2E blueprints and then went to DDD, and then bringing back those DDD concepts back into Java E, back into Jakarta E. That was the original purpose of the Cargo Tracker project. So in this particular project, that's really what I'm going to show you. I'm going to show you the purpose of this project is to show you that, hey, here's how you concretely do DDD-based development using Jakarta E as a technology. Now, let me tell you, the other thing I should mention, and I need a little bit of interaction from you guys, so do pay attention to this part here. This material is actually a 3 or 4 hour workshop, so it's pretty extensive. I'm obviously, I do not have 3 to 4 hours to sit down with you folks. So I do have to, but you can meaningfully deliver this talk actually in an hour. Otherwise, I wouldn't offer it. So, but you do have to make a choice, right, as to how to deliver the talk. And there's a couple of different ways that this talk can be delivered, and it's up to you how you want to see it delivered today. So I'll describe what those pathways are. So one option is for me to retain mostly a DDD focus and mostly explain DDD to you with a little bit of explanation of how it maps to Java and Jakarta EE in the end. So this pathway is suitable for an audience, a majority audience that really doesn't know DDD that well. And it's really the DDD concepts that need to be explained. The other pathway is making the assumption that most people that have come to the talk already know DDD, and basically they're wanting to see how those DDD concepts map to Jakarta EE in particular, and a little bit more deeper dive on that part, right? So in an hour time frame, or now about 45 minutes time frame, you do have to make a choice. So here's what I would like you to do. So take a moment. I'm going to pause for a little bit, a minute or two. If you would like a more of a DDD based focus, type in the word DDD. If you want more of a Jakarta EE focus, type in the word Java. And then we'll do a quick poll, okay, of the audience. How many people want a DDD focus versus how many people want a Java focus? And we are going to do the rest of the presentation in that way, right? So we'll determine what focus area, what it is that we want to focus on more in the next 45 minutes or so. And of course, after that, you can do your own research. That's the whole point of the talk. It's not a one and done thing. I'm going to, if you will, leave you with resources and homework that you can carry the talk forward. So I'm going to pause for a few minutes. And then I'm going to look at the input and output, and I'm going to sort of trust the moderator to tell me, okay, what pathway are we choosing in the next 45 minutes?
Yes, Reza. So audience, please give your vote. If you are looking into Java pathway, please post Java, or if you are looking into DDD pathway, please post DDD. Reza, we got 3 votes on DDD.
Okay, fair enough. Let's move ahead in that direction. It's last call. If you have an opinion, please make that known. Otherwise, we're just going to go with the DDD route. Okay. So, all right. Let me move forward, and then I'll if there's continue to be an opinion, keep posting them. I can try to switch directions if our directionality changes. So that's not a big deal. All right. So nice thing about DDD is there's a DDD community out there, and other than Eric Evans's book, there's been a lot of material that's been written. It's still a vibrant community in the DDD community, not as vibrant as it used to be, say, about 7 or 8 years ago, or 10 years ago, when things were just coming up, and you had things like the Cargo Tracker project and whatnot, and various other projects like that. But there's a lot of material out there that you can actually just reuse. So I actually am taking advantage of that fact in this talk. So for example, this particular diagram here, these are the basic building blocks of DDD. And this is not something that I came up with. In fact, this is mostly just a translation of what's in Eric Evans's book. Somebody else came up with this diagram. But if you understand this diagram and you understand the components in this diagram, you basically understand about 60-70% of what's in DDD. So we'll actually spend a little time with this particular diagram. Um, like J2E blueprints and Gang of Four design patterns, actually what DDD really is that it's a way of thinking. It has an end objective in mind, a philosophy in mind. But other than that, it's actually just another set of architectural blueprints, literally nothing much more. And it really comes down to understanding what these are and what these design patterns are when they apply, and having a general idea of how that should be implemented in Java or Jakarta EE. That's really what it comes down to. So let's talk about the philosophy first. So the philosophy of domain-driven design is that all aspects of your software development should model and mirror what you see in the real world. So if you're developing a hospital management system, then all parts of your application, whether that's your UI screens or the objects that you have in your system, Java-based system, or even the database structure and fields, table names, column names, all of those things should reflect very closely how your real world problem that you're trying to solve should look like. So you should have tables and columns and objects that look like, that are named things like hospital and patient and medication and bed and visitor, doctor, nurse, that kind of thing. Like that. That's really how your entire software world should also look like. It should look like your real world, exactly how things look like in the real world. Same thing with banking systems, right? So you'll name things account and customer and transfer and bank and teller, so on and so forth, right? So whatever it is that you're developing software for, the implementation of your software down to the lowest level detail should also look like the real world. And this is really what object-oriented development is supposed to be about, right? That's why you do have object-oriented development, is that it is supposed to be able to do that. It gives you the correct amount of structure so that you can model your software like you would the real world. So ultimately, this entire DDD concept is in a way of thinking model-driven design, right? So, but then the model is whatever the real world problem that you're trying to solve really is. Why would you do that? Well, there's several key reasons why. One reason is that it actually makes your job as a software developer a little bit easier, especially when you're interacting with your users, especially when you're interacting with your people in the business domain where your requirements are coming from. There's no translation gap. And literally, that's the word that's used in the DDD community of translating those real world requirements into software because your software already looks like the real world. The other thing that DDD makes easier is maintenance. So when you have software that is structured in this way and it looks like the real world instead of some funky, odd computer names, it makes maintenance easier, especially for somebody that is just coming into a project, because things look like they should, if you will. So that's the fundamental idea of what DDD tries to accomplish. And it does that through this small catalog of design patterns. So let's take a look at each of these design patterns, and these are the key ones. The first one is something called an entity, and it's the like a fundamental unit of object-oriented development and a fundamental unit of DDD. Basically, it mirrors something in the real world. It's usually a noun of some sort. So, all those examples that I give you were probably entities, right? So, a patient, a doctor, a nurse, a hospital, those are all entities, things in your domain. In DDD, that's what we call it. Your application domain or your business domain. Those are all objects. These are all entities. Entities actually will have both a name, of course. They'll also have data that they encapsulate in one way or the other. but they also have behaviors as well, just like doctors and patients have behaviors, right? That your business logic, it also is supposed to have that business logic embedded with it, the entities themselves. Entities, the other key characteristic of entities is that they're going to be uniquely identifiable. So they will have an ID of some sort. Think of it as sort of tables, but not exactly, right? So a database table will have a primary key, and similarly, entities will have a unique identity of some kind, other than having data and behavior. Closely related is this concept of value objects. So value objects, just like entities, are also nouns. These are things in your business domain. There is a little bit of a differentiator between entities and value objects. And the key differentiator is that a value object does not have an identity, does not have an ID of its own. It does have a name, it does have data, it does have behavior, doesn't have an ID. You can think of these as sort of modeling artifacts. This is when, in an object-oriented world, one object is wholly owned by the other. So it is entirely encapsulated by the other. Examples help in this case. So let's take a look at a object in your system that may be called address. So unless you are developing a sort of a postal system, address usually is not that important enough to warrant its own ID. It's sort of like a ancillary. It's a way of better organizing the data, but that's about it. So in your employee object, you might have a address field to it, if you will, address object embedded within it, if you will. Same thing for a hospital or an office, right? You'll have an address, but the address itself is not important enough to warrant its own ID. It's just sort of a way for you to better model things. That's all. So that's what a value object is. Next one is aggregate. An aggregate one is it's a little bit hard to understand unless you begin to develop your system. And then when you begin to develop your system, it all sort of clicks into place, and it makes a lot more sense than it does in theory. So you'll see this in the same thing. When I get to the code examples, you'll better understand what an aggregate actually is. So conceptually, what is an aggregate? An aggregate is basically a closely related set of entities and value objects. That's what an aggregate is. Basically, what happens is in a real-world system, in most non-trivial systems, you will probably have somewhere in the neighborhood of a few hundred objects, or at least a few dozen objects. And when you map these objects out, or even more or less simplistically, when you map your application out in the database, you will see that some objects and some tables, if you will, are more interrelated to each other than others. So they have more has a, contains relationship with them. In terms of databases, you'll see more foreign keys between certain tables than others. So what happens is really you have this large mapping of things in the real world, but some things are more closely related to the other than the others. So in a hospital management system, probably doctors, nurses, and patients are pretty closely interrelated together. And things like accounting systems in that business domain, are a little bit different, right? So inpatient, outpatient treatment, ambulances, those are probably a little bit more distinctly different. These are two different subdomains, if you will. And now we're getting into something called a domain context. I'll talk more about domain context in a moment. But basically, these are small clusterings of entities and value objects that are more interrelated. Usually, in each aggregate, there will be an aggregate root, one entity typically that is more important than the others. And that's how we usually name aggregates as well. And again, you'll see this in the code example better. At least for now, that's the concept, right? It's groupings of entities and value objects in your domain. Next is repositories, and this is sort of an easy one. in some way. So if you're familiar with the data access object pattern, and believe it or not, this is another J2EE pattern. This is really what it is, except for DDD. So it is a object whose primary purpose is to take something in your application that is an entity or value object and translate it to its database equivalent. So it's literally just a translation layer between the Java world and the uh, the uh, the database world. That's what a repository is. The difference between data access object and repository really is the granularity. So data access object typically is one data access object per table. And then the actual objects, what they produce is really just DTOs or data transfer objects. And then you create entities on top of that in another layer. That's what happens in J2E blueprints. In DDD, that's flipped around. So basically, what a repository is supposed to produce is actually the aggregate root. So it will be each aggregate root will have a repository, not each entity, not each value objects, not each table, but each aggregate root should have a repository. And its job is to do everything that it needs to construct an aggregate root and send that aggregate root up to the higher levels of the application. So it's like a more powerful, more granular DIO, and there'll be fewer of them, okay, in a DDD-based system than typically you would have in a J2E blueprint style application. Next is factories, and this is directly a creational pattern from the Gang of Four design patterns, and its purpose is exactly the same. But there's a specific sense in DDD when you talk about factories here. Basically, what it is that when you construct an aggregate root, and even when you construct just certain entities, just calling the new operator and setting some data is often not enough. Basically, these projects, these aggregate roots and entities are so complex. Just the construction of it is actually, let's say, in the neighborhood of 30 or 50 lines of code. And instead of copying that code wherever you need this object created, basically what you do is you create a creational factory. And these factories' only job is to house the logic that you need to construct an aggregate root, or construct, in some cases, more complex entities. So that is what a factory is. Literally the same purpose in Gang of Four design patterns, except for something that makes sense in the DDD world. Last one that I'm going to talk about is services. So services, the problem is that this terminology came about before things like SOAP and REST became popular. So nowadays, when you say services, unfortunately, people immediately think about REST-based services. It used to be people immediately thought about SOAP-based services, but that's not the service we're talking about here. So in DDD parlance, service is a little bit different than that. So service, while value entities and value objects are representation of nouns, services are actually representation of verbs. So the problem is when you take a problem domain, there are certain actions, certain things that you do that are actually just as important as the things themselves. So you have to take some examples to really understand what I mean here. So let's say you were developing a transportation-based system. One of the key things that you do there is actually it's a logistics and transformation-based system. So one of the key things is dispatch, actually. So dispatch is basically the act of taking or scheduling or dispatch or whatever you want to call it. So basically, scheduling may make more sense. So scheduling is like, okay, here's all the stuff. Here are my routes. Here are the trucks. Here's the stuff that needs to go on the trucks to a warehouse. But you need to all figure all of that out, right? You need to provision it, if you will. So provisioning or scheduling or that kind of thing, dispatch, is actually so important that it warrants a top-level space in the model. So that is what a service is. It's a domain service. Same thing with in banking transfer. Bank transfers, transfer monies between banks or between accounts can be very complex. It's a verb that deserves its own place. It cannot be modeled just as behavior of an entity or value object. It needs to be modeled on its own. In an insurance-based system, it's underwriting, right? The task of underwriting is actually very important enough to warrant to be a service instead. So this is really what domain services are. Typically, it's just, it'll be like a name close to a verb or a verb sounding noun, if you will. And it'll typically only have one or two bits of behavior, not that much data. And what it does is that it just acts upon a bunch of different entities and value objects. That's what a domain service typically does. So there's an example in the example application, but you can come up with many other type of examples as well. So let me stop here for a moment. I did see a question posted here. For people from Spring Framework, services are classes that has business logic. No. That's not the case. So you're talking about what you're mentioning is called a session facade. So the business logic, typically 9 times out of 10, you want the business logic to be actually as behaviors in entities and value objects. Yes, in certain cases, a domain service can encapsulate business logic, but actually what its primary purpose is to coordinate across complex operations of entities and value objects. Now, in some cases, it may have its own own business logic, but by default, you should avoid doing that. And by default, you should try not to have services that have a bunch of business logic in it. It may be inevitable, like that there's no other point, there's no other way. But you could, by default, you should try to actually model business logic as behaviors of value objects and entities. So this is another one of sort of the domain-driven design thinking. Okay, so let me stop, and if you have any questions, keep posting them. I'm reading. I'm taking a quick pause and reading my questions now. Can you discuss the role of value objects and entities in DDD and how they're represented in Java? Do both value objects and entities have a table? Let's get to that when we take a look at the example. So I'm going to defer that for a little bit. Especially, it'll be obvious when I talk about how to entities and value objects map to Jakarta EE, in particular in JPA or Jakarta persistence. I think that'll answer your question. How do you structure a Java object to best reflect the principles of DDD? Again, we're going to get into that in a moment. When you take a look at the code examples, you'll see that for yourself. Okay. Any other
Reza,
questions?
I have a question. Sorry, I lost my internet for a moment.
Yeah, sure.
I'm coming to the basic concept, like when it comes to entities and value objects, how do we differentiate basically one object as an entity and one object as a value object? Is it based on the requirement? It changes always?
No, the primary differentiator is the value objects. A value object will not have an identifier of its own. So it will be fully encapsulated by an entity. That's the primary differentiator between a value object and an entity. They're rare, right? So value objects are not that commonplace. Majority of objects in your domain are going to be entities. In certain cases, it makes sense to have value objects also to better represent the data. So again, having an employee entity and an address value object within it, is an example, right? So that's a same thing. If you want to have phone number, it's not important enough to warrant its own entity, yet it's complex enough to warrant its own object. So that's what a value object really is. So there's no reason for those to have IDs. Now, there's exceptions, right? So if you're developing a postal system, probably address is one of the important things. So in that case, address would be an entity. So yeah, the key differentiator is, and a value object doesn't have an ID. So this will make more sense again when even more sense when we talk about how do they map to Jakarta EE or JPA. Essentially, I'll tell you right now, entities typically will be JPA entities, and they'll have an at ID or at ID class annotation on them, hence they have an identifier. Whereas a value object will typically be a JPA embeddable. So think about how the frequency of embeddables versus entities in JPA. Embeddables are relatively rare, but they do occur. So a value object would typically be mapped as an embeddable, as a JPA embeddable.
Okay, got it.
Okay, let's move forward. I don't see any other questions so far. So, and we're doing okay on time. All right. Separating the concerns. So here's the another thing that may or may not apply to all DDD-based systems, but in general they do. So so all of what we talked about so far actually is in the space of the domain layer. So entities, value objects, domain services, factories, these are primarily all, oh, I'm not sure what happened there. I'm going to reshare my presentation. I think for some odd reason, my PowerPoint crashed. That has never happened before. Okay, let me get back to my slide where I was at. All right. You can have so all of what you talked about actually is in a specific layer, and you don't have to use layering with DDD, but a majority of people do recommend it for enterprise systems. And I'll explain in a moment why. So all of the things that we talked about are in the domain layer. Now, if you are a DDD, like early DDD purist, you would have said, that's all you need. Right? You just have these objects, and there you go. What happens when you do that is a lot of non model behaviors, non-model logic, non-business logic actually bleed into the domain itself. Because when you write a software application, you're not just dealing with real world objects, you're also dealing with systemic concerns. So this is the reason why it's better to have layers, and majority of the layers other than the domain layer actually is nothing to do with the business domain per se. It's more a reflection of the fact that you're writing software, and software has different concerns than just the real world. So that's actually where you put all of your software concern is all of the rest of the layers. So these are the typical layers. They do not have to be reinvented. Think of these as design patterns as well. Okay, so primary one, the one I'll talk about first is interfaces. So an interface is basically interacting with anything in outside of your system. It could be a human user, in which case an interface is your UI. It could be another system, in case of system to system development, in which case an interface would be something like a batch process or a file processing system, where you're consuming files and producing files. Or it could be SOAP services, or these days REST-based RESTful web services, and you're just taking a request and maybe issuing on the other requests, and that is your interface. So a set of RESTful services is really your interface. That could be. Next layer down, and it's an optional one. It doesn't have to always be there. You can directly invoke your domain from interfaces if you like. But in some cases, it is useful to put in an application layer. And the application layer actually is sort of like domain services, but a little bit higher level. So these are the primary behaviors that of primary business use cases that you have, the large gain, coarse grain business use cases. And each of these will be reflected in something called an application layer object. And then lastly, you have interfaces or infrastructure. And that is things like scheduling transactions, asynchronous processing, you name it. In fact, in Jakarta EE, this is basically what Jakarta EE is. This is the stuff that Jakarta EE actually gives you. So in most cases, your infrastructure is as simple as putting an annotation on an object, and that's about it. That's your infrastructure, so to say. Writing some JPA code, that's your infrastructure, and that's about writing some JMS code. That's your infrastructure, and that's about it. So infrastructure can be cross applied into all of these layers, or it can be its own object as well. We have examples of both in the application. Now, let's begin to talk about how these things map to the Java world and Jakarta EE in particular. So basically, if you're writing faces beans, facelets, faces like XHTML files, JSPs, these are basic servlets. These are all basically at the interface layer objects. This is what they really are. These are various types of interface. Any object that has implements those things, it really should is an interface layer object, and it may have its own design patterns. In fact, MVC is one, right? So you often apply the MVC design pattern in the interface layer of the application. Same thing with RESTful web services, WebSockets, batch processing. If you're using these APIs and that your primary annotation on these objects is along the lines of WebSocket or RESTful services or batch, that's in the interface layer. It's interface layer object on its own. The application layer will typically be modeled by either EJBs or CDIs with service annotations on it, like transactional, asynchronous, scheduling, so on. Enterprise means is especially useful in this context because you're talking about business use cases. So they are essentially units of behavior, large units of behavior in your application. So it's a perfect fit for enterprise Java beans because you can declaratively apply things like transactions, security, asynchronous processing, scheduling right there just via using annotations. But again, you can model the same thing using CDI and then a la carte add all of your services that you need, same difference. Entities will typically just be, directly speaking, 9 times out of 10 is just going to be a JPA entity. Literally, that's what it is. So you'll have an ID, you'll have data, your map data, and then you'll also have behavior, not just getters and setters, but behavior as well. Next is value objects, and again, there's a direct mapping in Jakarta EE systems because literally, if you have an embeddable annotation, that's a value object basically, for the most part. It's not as cut and dry in that, but for the most part, that's really what it is. Then you have infrastructure, and like I said, like a lot of the Java Mail API, interceptors in writing interceptors in CDI, using the REST client, even low-level persistence code. This is all part of your infrastructure. So these should be infrastructure level objects. You should encapsulate them in their own objects as part of infrastructure. Logging is another example. And lastly, you have repositories. And believe it or not, I've seen Adam Bean do this. Basically, the entity manager sometimes is just good enough to be your repository layer for the most part, right? So if you design your entities well enough and you're lucky enough, you don't need another separate repository object. Literally, you can just use the entity manager directly to do entity-based interactions, and that is effectively your repository. But in more complex cases, you do want repository objects encapsulating the behavior of the entity manager. Or in case of Jakarta EE11, or if you're using the Delta Spike data model or Spring Data JPA, literally there's an interface called a repository. And that is, it's not just, I'm using Spring Data JPA and hence I'm using repositories and hence I'm doing DDD. It's not as simple as that though, right? It's called repository, but you still need to have domain-driven design thinking behind it, right? So again, repositories are supposed to be more coarse-grained, a little bit more complex, and typically mapped to an aggregate root. Okay. All right. Moving forward, bounded context. I'm going to skip it over just because there's not really enough time. But it's very useful in terms of thinking about microservices. Let me introduce the project. Okay, so I'm going to hop over into. At this point, there's actually no time for a demo. I'm just going to directly show you the code and the website. So let's go on to the website first. All right, so here's the website. And in the website, here's how it looks like. This is all of the stuff that I just explained to you in this particular talk. Okay, it'll tell you how to get it started. It's a simple. If you don't want anything else, just go download it, and literally all you need to do is say mvn clean package cargo run, and it'll run the application for you. It's as simple as that. You can set it up in IDE. I actually have a demo of that, so you can go ahead and do that as well to begin exploring. It runs on a couple of different runtimes. So in addition to Payara, you can run the Cargo Tracker on Glassfish or OpenLiberty. That's how you do that. This explains all of the relationship between J2E Pet Store and DDD. This explains to you the basic concepts of DDD, just like we just covered. And then it'll also tell you what are all of the different Jakarta EE features that are actually used in this application. So the application, as you can see probably from the website, it's in the logistics domain. It's ships basically transferring containers across the world. That's what the system is. Let me increase the font size a little bit so I can begin to show you the code. I won't be able to show you a lot of the code, but hopefully I can show you enough. Okay, so let's start by taking a look at the domain layer itself. Okay, so if moving here, this is our main domain context. Okay, so first thing you'll see is that how the packaging is done. All right, so notice this reflects the layers. So this is where we're segmenting things by layers. So you have the application layer, the infrastructure layer, the domain layer, and the interface layer, right surface right here. Now let's hop into actually the application layer. Let's start with the application layer. That's useful now. So the main one, there's a couple of different application layer objects here, but the main one actually is booking service. Makes sense, right? There's a booking interface in the application. When you see the application, there's booking as a key part, and this is basically modeling, those business use cases and that are surfaced in the application. Let me increase the font size here a little bit so you can take a look at the code. It's called booking service. It's an interface. This is it's an application layer object. Remember, it's not a domain service, by the way. So the high-level use cases are booking new cargo, requesting possible routes given a booked cargo, changing deadline, and also changing destinations. These are the high-level in the UI. These are the high-level actions that you can take. So basically, these are manifestation, nothing much more than ways of organizing your domain. So if you look at the implementation of default booking service, let's take an example of, for example, doing a new cargo. Okay, so as an input from the UI layer, you will get a tracking ID. You will get an origin and a destination. You will get an origin, destination, and a deadline. That's your key bits of data. Those three key bits of data. And what you will do is you will begin constructing your domain. Okay, so you'll get a tracking ID from the repository layer, origin and destination entities. You will create a route specification. Then you'll create your aggregate route, which in this case is actually cargo, and you will feed it the route specification. And then you are simply invoking a repository object to store this particular aggregate route. Okay, and as you can see, it's the repository is named by aggregate route. So there's no business logic here whatsoever, right? So the business logic actually is in the domain layer. You'll see that in a moment. So that's the application layer. Now let's take a look at how that looks like in the domain layer. Okay, so in the domain layer, you will see that there's models and services. Here's a service, right? So as you can imagine, it's a logistical system. So one of the key domain services is routing service. And literally what it does is that it says, okay, for a given route specification, give me what are the possible candidate itineraries. It's one thing. It's literally that domain service example that I was giving you before. That's literally all it really does. Now, under the model, you will see that it is organized by aggregate root. So the key aggregate roots in this system are cargo, handling, location, and voyage. So if you look at under the cargo aggregate root, you will see obviously cargo entity is the aggregate root is in this aggregate. That's the key entity. But there's other entities in other entities and value objects that has a is a relationship or contains relationship with cargo. So these are things like delivery, handling activities, itinerary, leg, route specification. So there's a bunch of different objects that ultimately is used by or contained by the cargo aggregate. So the cargo aggregate entity itself is an entity, as you can see, it's a JPA entity. It has data, it has an ID, right? There's the ID. In this case, it's a simple ID. It has a bunch of data, so things like tracking IDs, origin, route specification, itinerary, delivery. These are all of its data. It also has behavior. Okay, so here's the behavior. Specify new route. This is where actually all the business logic is going to go. Things like get delivery progress. Okay, these are all business logic. These are behaviors of this cargo object. And then there are also embeddable objects. So delivery is an embeddable object, for example. So it is not an entity. It is a value object. Okay, that's helping you model the cargo better. So in here is going to be things like it also will have data. So things like transport status of the cargo, lost known location of the cargo, the current wires the cargo is on. These are all delivery related. ETA, current ETA. These are all aspects of the cargo modeled in a value object. And this guy will also have business logic in them, right? So if you look at calculate transport status, all these calculate methods, these are all the application business logic actually resides here. So now let's take a look at a simple example of things in the infrastructure layer. Okay, so there's several different types of infrastructure code that I'm using. I'm using CDI events, logging, messaging, and persistence. Easiest thing to explain is implementations of repositories. Okay, so this could be, if you're using Spring Data JPA and you're lucky, this could just be an interface. In my case, it's actually an implementation. It's an application scope CDI bean. I'm injecting the entity manager in here, and I have a bunch of complex CRUD operations built into this built into its repository implementation finders, if you will. Lastly, if you look at the interface, I have a bunch of interfaces. The key ones are booking and handling. If you look under booking, it will have a facade, and it also has some web objects and SSCs. So if you look at the SSC, for example, there's a real-time cargo tracking service. So this is literally a RESTful service. It's in the interface layer. And it ultimately injects the repository directly and acts on the repository. Okay, so if you, for example, if you want to get basically all of the service sent events, you will do a find all on the cargo, get all cargos, and create a broadcast broadcast channel for each cargo. So it's literally a service. It's part of the interface layer. Same thing, you'll see UI layers, you'll see factory object implementations, and so on. So if you begin taking a look at the code, which I just barely introduced at a very surface level, you'll see examples of all of these things, and the website will actually tell you how each of these objects in the application actually maps back to DDD concepts. So to summarize, DDD is a great architectural blueprint for non-trivial Java applications. I would say for any Java application, you should start by attempting with DDD in mind. It's a natural fit for Java. It's especially natural fit for Jakarta EE, as you will see when you look at the application. Literally, in many cases, you have annotations that directly map to DDD concepts. The application itself is a very useful starting point. In order to get into the DDD mindset. Here's a few resources. These resources are on the website itself. Of course, the project itself, and I gave you also a bunch of simple, not Eric Evans's book. Don't get into that book so quickly. It's kind of heavy book. But there's other more easier resources that you can get started with. I give you a couple of examples of that. And also, lastly, if you want to learn about Jakarta EE, I give you some resources for that as well, namely the official tutorial as well as the official examples. You can learn. That's not what Cargo Tracker does. It's not designed to teach you Jakarta EE. But if you want to learn Jakarta EE, there's other resources for you to do that as well. Okay, so that's about it. In terms of my slide deck, I'll take any last-minute questions that you may have. I think we're at time, and I think it's quite late for you also. So I don't want to take up your time unnecessarily. Yeah, like I said, if there's any last-minute questions, I'll take them. Otherwise, I guess it's a wrap for us.
We have a question, Reza. What is the initial exercise would you recommend for teams to start adopting DDD approach?
I'll start by exploring the application, literally. Download the application, play around with it, read the material that's on the website, and then basically examine the application and maybe try to make some simple changes to the application. Some simple behavioral changes or adding a screen or what have you. In my opinion, that's a good way to start DDD. DDD, there's no hello rule for DDD because there's many different concepts in DDD. It's not for simple systems. If you write a hello world system, that does not need DDD. You need DDD in a more non-trivial, realistic application. So getting started with Cargo Tracker is probably would be my best recommendation. Okay. Any other questions?
We don't have other questions at the moment.
All right, excellent. Thank you for having me. Have a good evening. Hopefully I get to see you in person one of these days. If not, I'm happy to keep delivering, these sort of virtual talks as time permits. But anyway, I think that's a wrap for today. Do get in touch with me if you have questions after the fact. This is part of the reasons why I deliver these talks. Also, I'm easy to find. You can find me on. I have my own personal website. It has a contact page in it, and all of my contact details are there: email, Twitter handle, whatever it is that you need. All right. With that, I guess I'll wish you a good evening.
Thank you so much, Reza, for joining us and spending time with us and explaining these concepts. I hope to see you soon with another talk.
Yeah, fair enough. Yeah. See you later.
Yeah. See you. Thank you so much, guys, for joining us. Please, if you want to have a nice rest of the day.